All right, so we got as far as example 3 today in class, and we were right here. We had not written this yet. We were to the point where we were saying that PQ is 5 units, PR is 7 units, and RQ is about 8.6. Distance formula or Pythagorean theorem finds that. Okay, so you might want to label that on the picture. And then it really doesn't even matter that it's on a grid. It's just a right triangle where you're trying to find a missing angle. Either R or Q you could find first. I chose to find R first, and I said the tangent of R is equal to 5 over 7. That means the inverse tan of 5 over 7 equals R. So in my calculator, I'm going to do inverse tan of 5 over 7. Inverse tan, 5 over 7, gives me 35.53, so that's about 36 degrees. So R is about 36 degrees. This is 36 degrees. Then this one up here is 54 degrees. And I have solved my right triangle. Remember, solving your right triangle means finding all the missing side lengths and all the missing angles. Let me point out on this one that it is better to use the 5 and the 7 because the 5 and the 7 are whole number values than to use the 8.6 that we rounded to get. So it's going to make it a better answer. Let me go ahead and do example 4. Coordinates of the vertices of RST are negative 3, 5, 4, 5, and 4, negative 2. So once again, we have a right triangle. The distance from R to S is 7. The distance from S to T is also 7. And that actually tells me that this side is 7 root 2, which is about, let me change it to a decimal. Remember, if it's an isosceles right triangle, that's a 45, 45, 90. So 7 times the square root of 2 as a decimal is 9.89, which is about 9.9. Okay, so I'm trying to find either missing angle in this right triangle with 7, 7, and 9.9. So I'm going to go ahead and start by finding T. And again, I'm going to use the 7 and the 7, not the 9.9, because the 9.9 was found by rounding. So the 7 and the 7 would be more accurate. So the tangent of angle T gives me 7 divided by 7. So that means the inverse tan of 7 over 7 will tell me what T is. So inverse tan of 1 should tell me something I already know, which is that I have a 45 degree angle. Okay, and I should have already known that because it's a 45, 45, 90 triangle, and the reason I know that is because it's isosceles and right. Every right isosceles triangle has angles of 45, 45, and 90. Okay, on these down here, this is just typing it into your calculator, just hitting the second button and then tan and then 2.1. So go ahead and pause the video if you want to, try these, and then come back. And when you come back, here comes the key. So you could check your values. And this is what you should have gotten. All right, on number 13 down here. Let's go ahead and work 13 together. And that's the last one I'm going to do for you on here. And let's see, we have a right triangle with legs here of 3.1 and 8.9. And that's all we know. So we have R, we have Q, we have P. Okay, we need to start by finding either angle R or angle P. Doesn't really matter which one. I'm going to choose angle R. So for angle R, tangent of R equals 8.9 over 3.1. And I knew to use the tangent because for R, this is the opposite side, this is the adjacent side. So now, excuse me, if I do inverse tan of 8.9 divided by 3.1, I get approximately 70.79 degrees, so about 71 degrees here. Subtract from 90, and we find that this angle is 19 degrees, and that's the answer for 13. So you shouldn't have any problems finishing 14, 15, 16, 17. If you just want to finish through 15, that's fine. If you're going to go ahead and start that other homework assignment that I mentioned on eClass. That's for 4th period. So, see you tomorrow.